Okay, today we'll see what some examples related to what simple harmonic motion. The first example says that when the displacement of simple harmonic motion is 1 centimeter, its velocity would be 2 centimeter per second. And when the displacement is 2 centimeter, its velocity is 1 centimeter per second. Then what will be the amplitude and time period under this simple harmonic motion? እዚህ ጋር ምንድን ነው የሚለን? We have given that 1 centimeter, the temporal displacement of the particle at 1 centimeter, there is what velocity of what 2 centimeter per second, and another distance when the displacement is 2 centimeter, its velocity is 1 centimeter per second. Then what will be the amplitude? አምፕሊቱድ እና ታይም ፔሪዮድ ምን ይሆናል ነው የሚለው። እዚህ ጋር አንደርስታንድ ለማድረግ መጀመሪያ ይህን ከመስራታችን በፊት የቴምፖራሪ ዲስፕሌስመንት እና ቬሎሲቲ አዝ ዌል አስ ዋት አምፕሊቱድ ሪሌሽን ምን ይመስላል የሚለው ነገር ማየት ግድ ይለናል ማለት ነው። ኦኬ፣ ወደ ጥያቄው ስንሄድ መጀመሪያ ምን ማድረግ እንዳለብን ማወቅ አለብን ማለት ነው። ኦኬ፣ እዚህ ጋር ጊቭን ምን አለን? x1 at x equals to x1 equals to what 1 centimeter, the v1 is equal to what 2 centimeter per second, 2 centimeter per second, and also at x2 equals to what 2 centimeter, v2 would be 1 centimeter per second. This the given quantity. Okay, required amplitude. What will be the amplitude? A, how much, and time period, how much? Okay, from this one, first of all, we must determine what the relation between what the temporal displacement, velocity, and amplitude. We know that v speed is equals to what angular frequency under root amplitude square minus temporal displacement x square, which is the general formula for simple harmonic motion. Okay, now v1 is equals to omega amplitude times under root a square minus, omega is not amplitude, rather it is angular frequency, times x1 square. The same is true v2 is equals to omega times under root amplitude square minus x2 square. Okay, then v1 over v2 is equals to omega times under root amplitude square minus x1 square over omega times under root amplitude square minus x2 square. Okay, finally we have v1 over V2 is equals to under root amplitude square minus x1 square over amplitude square minus x2 square. Both sides square, we get v1 square over v2 square is equals to amplitude square minus x1 square over amplitude square minus x2 square. Okay, then finally we have given v1 means that is 2 square over v2 is 1 square is equals to amplitude square minus x1 square, which is 1 square over amplitude square minus x2 square, which is 2 square. Then this implies that 4 is equals to amplitude square minus 1 over amplitude square minus 4. Okay, then crisscross, therefore this is equal to 4 bracket amplitude square minus 4 equals to a square minus 1. Then distribute 4 a square minus 1 6 is equals to a square minus 1. Then finally 3 a square is equals to 1 5. This implies that a is equals to 5 square. This is then a is equals to under root 5. Okay, then this is the final required, or the first required of amplitude. Then the second one is time period. Time period is given by 2 pi over angular frequency. We know that angular frequency, that is from v1 is equals to omega angular frequency under root amplitude square is, which is 5 minus 1. We have 2 is equals to omega under root 5 minus 1, that's 2. Then finally omega is equals to 1. Therefore when you substitute this value, you get time period is equals to 2 pi second. This is all about today's lesson. Thank you so much.